Hello everyone, my name is Tejashri Divakar Dasi. I am from Sri Siddheshwar Women's College of Engineering, Solapur. I am pursuing BTech from Computer Science Engineering currently in first year. So I am here to explain one of the concepts of matrix, that is eigenvalues and eigenvector. So in this lecture, we will see first introduction, what is eigenvalue, what is eigenvector, then procedure to find eigenvalues and eigenvector, and lastly an example based on eigenvalues and eigenvector. So let us start. So we will understand first what is eigenvalue. The roots of characteristic equation are known as eigenvalues, where determinant a minus lambda I is called characteristic equation. We will see what are the terms a, lambda and I here. So a is the square matrix of order n by n. Lambda is a scalar and I is the identity matrix of same order n. Now we will understand what is eigenvector. Corresponding to each lambda, that is eigenvalue, there exists a non-zero column vector capital X which is equal to x, y, z, which is known as eigenvector. Now we will move forward and see the procedure and steps to find the eigenvalues and eigenvector of a given matrix. Procedure to find eigenvalues and eigenvectors. Let A be any square matrix of order n by n and I be the identity matrix of same order as A, that is n by n. As we have seen, the roots of characteristic equation are known as eigenvalues. So consider the characteristic equation, that is determinant A minus lambda I, where A is the given matrix of order n by n, lambda is eigenvalue and I is the identity matrix. Here determinant A minus lambda I is equal to the matrix A minus lambda into identity matrix. Multiply lambda to the identity matrix. As we have multiplied the lambda to identity matrix, subtract lambda from principal diagonal elements of matrix A. We get a matrix as shown here, which is equal to 0. On simplifying in general, we get a cubic equation, that is lambda cube minus s1 lambda square plus s2 lambda minus determinant of A equal to 0. We will see what are the terms s1 and s2 here. So S1 is the sum of all the principal diagonal elements of a matrix A, that is A1 plus B2 plus C3. And S2 is the sum of minor of A1, minor of B2 and minor of C3. Here minor of A1 is B2, C2, B3 and C3. Minor of B2 is A1, C1, A3 and C3. And minor of C3 is A1, B1, A2 and B2. Thus, solving this cubic equation, we get 3 values of lambda. We have understood the procedure to find eigenvalues. Now, we will see how to find eigenvector. So, to determine the eigenvector, consider the matrix equation. Consider the matrix equation A minus lambda I into capital X equal to 0. Now take augmented matrix A0. Solve the set of equations to get the solution. Let us see now an example based on eigenvalues and eigenvector. Here, this example says that find the eigenvalues and eigenvector corresponding to the largest eigenvalue of a given matrix A. We will solve this and find the eigenvalues and eigenvector corresponding to highest eigenvalue. As we have seen the procedure, the eigenvalues lambda of a matrix A are found by solving the characteristic equation, that is determinant A minus lambda I is equal to 0. For a given matrix A, it becomes 1 minus lambda 1, 3, 1, 5 minus lambda 1, 3, 1 and 1 minus lambda equal to 0. That is, we subtracted lambda from given matrix, that is, we subtract lambda from principal diagonal elements of given matrix A. On simplifying in general above matrix, we get the cubic equation lambda cube minus s1 lambda square plus s2 lambda minus determinant of A equal to 0. S1 is the sum of principal diagonal elements, that is 1 plus 5 plus 1, which is equal to 7, that is S1 equal to 7. Similarly, we find S2, where S2 is the sum of minor of A1, minor of B1, where S2 is the sum of minor of A1, minor of B2 and minor of C3. Minor of 1, minor of 5 and minor of 1. So these are the minors of 1, that is 5, 1, 1, 1. And minor of 5 are 1, 3, 3, 1. Minor of 1 are 1, 1, 1, 5. So after adding these minors, we found the values of S2, which is equal to 0. Now calculate determinant of A. First element, that is 1, into this determinant, taking negative sign, and second element of first row into this determinant, plus third element of first row into this determinant. After solving, the matrix of A is given as minus 36. After solving, the matrix of A is equal to, after solving, the determinant of A is equal to minus 36. So the equation 1, that is lambda cube minus s1 lambda square plus s2 lambda minus determinant of A equal to 0 becomes lambda cube minus 7 lambda square plus 36 equal to 0. By solving above cubic equation, we get the values of lambda as follows, that is lambda equal to 6, lambda equal to minus 2 and lambda equal to. Here the largest eigenvalue is 6. As mentioned in question, we find the eigenvector corresponding to the highest eigenvalue, that is 6. Now let x equal to a column vector x, y, z be the eigenvector. Consider the matrix equation A minus lambda I into capital X equal. Taking augmented matrix A 0, we get the following matrix, in which we have now subtracted the value of lambda, that is 6, from principal diagonal elements. So 1 minus 6 is minus 5, 5 minus 6 is minus 1, and again 1 minus 6 is minus 5. Now reduce this matrix to echelon form, that is upper triangular matrix. Here we interchange R1 and R2, we get this matrix. Now performing operation, changing R2 such that R2 plus 5R1 and changing R3 such that R3 minus 3R1, we get this matrix. Now adding R3 and R2, we get matrix in echelon form. So here rank of A is, not equal to rank of AB. So the system is inconsistent. Also rank of A, that is R, is equal to 2 and number of unknowns, that is n, equal to 3. Since 2 is less than 3, therefore R is less than n, and as R is less than n, system has infinite solutions. It exists n minus R, that is 3 minus 2, which is equal to 1 independent parameter. Now we write above matrix in equation form. We get x minus y plus z equal to 0 and minus 4y plus 8z equal to 0. These two put z equal to t in equation 3. We get minus 4y plus 8t equal to 0. Therefore 4y equal to 8t. Therefore y equal to 2t. Now put the value of y, that is y equal to 2t, in equation 2. We get x minus 2t plus t equal to 0. That is x minus t equal to 0, and which is equal to x equal to t. X minus t equal to 0 and x equal to. So eigenvector, that is capital X, becomes a column vector t, 2t, t. put t equal to 1, we get capital X equal to 1, 2, 1. So the eigenvector of a matrix A for lambda equal to 6 is capital X equal to a column vector 1, 2, 1. I hope you understand this concept. Thank you.